Module 3, System Installation, Maintenance, and Repair Lesson 9 to 12. System Installation. Hello folks, welcome to Module 3 of this course and today's lesson on the installation of air conditioning and refrigeration systems. This session will explore the crucial aspects of installation procedures and delve into the significant considerations for system sizing and selection. Understanding these processes is vital for ensuring efficient, safe, and optimal performance of HVAC systems introduction. Air conditioning and refrigeration systems play a vital role in modern society. They provide comfort, preserve food, and maintain essential operations across various industries. The installation of these systems is a critical task that demands precision, adherence to industry standards, and an understanding of thermodynamic principles. This lecture will cover the fundamental installation procedures and the processes involved in system sizing and selection. Installation procedures for air conditioning and refrigeration systems. The installation of air conditioning and refrigeration systems involves several steps that must be carefully followed to ensure the system functions efficiently and safely. Let's break down the process into key stages. 1. Pre-installation planning. Site assessment. Evaluate the location where the system is to be installed. Consider factors such as space availability, exposure to elements, and ease of access for maintenance. Load calculation. Calculate the heating and cooling loads to determine the capacity requirements of the system. This involves considering the building size, insulation, occupancy, and heat-generating appliances. Regulatory compliance. Ensure compliance with local building codes and regulations, including energy efficiency standards and safety requirements. 2. System design and component selection. Selecting equipment. Based on the load calculation, select appropriate equipment that meets the required capacity while considering energy efficiency ratings SEER and environmental impact refrigerant type. Ductwork and piping. Design the layout for ductwork and refrigerant piping to optimize airflow and minimize energy loss. 3. Installation. Mounting units. Secure the evaporator and condenser units in their designated locations. Ensure they are level and properly supported. Duct and pipe installation. Install ducts and refrigerant lines, ensuring proper insulation to prevent condensation and energy losses. Electrical connections. Connect electrical wiring according to manufacturer instructions and local electrical codes. Verify grounding and circuit protection. Charging the system. Carefully charge the system with the appropriate refrigerant. Follow manufacturer guidelines to prevent overcharging or undercharging.
System testing and commissioning. Pressure testing. Conduct pressure tests to identify leaks in the refrigerant system. Correct any identified leaks before proceeding. Performance testing. Verify system operation by checking parameters such as temperature differential, pressure readings, and overall efficiency. User training. Educate the end users on system operation, maintenance requirements, and safety protocols. System sizing and selection. Proper sizing and selection of air conditioning and refrigeration systems are crucial for maximizing efficiency and comfort while minimizing energy consumption and costs. Below are the primary considerations for system sizing and selection. Load calculation. The accuracy of load calculations is paramount. Employ methods such as the manual J calculation to assess residential load requirements and the manual UN or equivalent for commercial applications. Load calculations should incorporate building characteristics, size, orientation, insulation levels, window types, and shading, occupancy patterns, number of occupants, and their activity levels, heat gains, appliances, lighting, and external environmental conditions. 1. Equipment efficiency. Choose equipment based on high efficiency ratings. Consider the seasonal energy efficiency ratio SEER for air conditioners and EER for refrigerators. Higher ratings indicate better energy performance and cost savings over time. 2. Environmental impact. Select systems that use environmentally friendly refrigerants with low global warming potential GWP. Additionally, prioritize systems with features like variable speed drives that reduce energy consumption. 3. Cost considerations balance the initial investment with operational costs. Higher efficiency systems may have a higher upfront cost but offer savings through lower energy bills. Consider the total cost of ownership over the system's lifespan. Executive summary. Here's a summary of pre-installation planning for refrigeration and air conditioning. Site assessment. 1. Evaluate the installation site for accessibility, space constraints, and environmental factors. 2. Identify potential hazards such as electrical or water sources. System design and selection. 1. Determine the required cooling capacity and select suitable equipment. 2. Choose the appropriate refrigerant and system configuration, for example, split, packaged, or central. 3. Consider factors like energy efficiency, noise levels, and maintenance requirements. Load calculation and analysis. 1. Calculate the heat load for the space or application. 2. Analyze factors like insulation, windows, doors, and occupancy patterns. Electrical and controls planning. 1. Determine the electrical requirements for the system, for example, voltage, ampacity. 2. Plan the control system, including thermostats, sensors, and relays. Piping and ductwork planning. 1. Design the piping and ductwork layout for efficient refrigerant flow and airflow. 2. Ensure proper sizing, insulation, and support for pipes and ducts. Safety considerations. 1. Identify potential safety hazards such as electrical shock or refrigerant leaks. 2. Implement measures to mitigate these risks, like grounding and bonding. Permitting and compliance. 1. Obtain necessary permits and approvals before commencing installation. 2. Ensure compliance with local building codes, regulations, and industry standards. Documentation and communication. 1. Create a detailed installation plan and schedule. 2. Communicate with stakeholders, including customers, contractors, and suppliers. Here's a summary of system design and component selection for refrigeration and air conditioning. System design considerations. 1. Load calculation. Determine the required cooling capacity based on factors like space size, insulation, and occupancy. 2. System configuration. Choose from options like split, packaged, or central systems, considering factors like space constraints and maintenance access. 3. Refrigerant selection. Select a suitable refrigerant based on factors like operating conditions, safety, and environmental impact. 4. Energy efficiency. Design the system to optimize energy efficiency, considering factors like compressor type, fan motor efficiency, and insulation. Component selection. 1. Compressors. Choose compressors based on factors like capacity, efficiency, and noise level. 2. Condensers. Select condensers based on factors like capacity, airflow, and space constraints. 3. Evaporators. Choose evaporators based on factors like capacity, airflow, and defrosting requirements. 4. Expansion devices. Select expansion devices like thermostatic expansion valves, TXVS, or capillary tubes based on factors like system capacity and operating conditions. 5. Fans and blowers. Choose fans and blowers based on factors like airflow, noise level, and energy efficiency. Additional considerations. 1. Control systems. Design a control system that integrates components like thermostats, sensors, and relays. 2. Piping and ductwork. Ensure proper piping and ductwork design for efficient refrigerant flow and airflow. 3. Safety features. Incorporate safety features like pressure relief valves, temperature sensors, and emergency shutdown systems. For maintenance access. Ensure easy maintenance access to components like filters, coils, and compressors.
Here's a summary of system sizing and selection for refrigerator and air conditioning. Cooling load calculation. 1. Determine the cooling load. Calculate the required cooling capacity based on factors like space size, insulation, occupancy, and internal heat gains. 2. Consider climate and weather. Take into account the local climate, temperature, and humidity levels. System sizing. 1. Determine the system capacity. Choose a system that matches the calculated cooling load, considering factors like system efficiency and safety margins. 2. Select the right equipment. Choose equipment that meets the required capacity, efficiency, and noise level. System selection. 1. Refrigerator systems. Select from options like top freezer, bottom freezer, or side-by-side refrigerators, considering factors like space constraints and energy efficiency. 2. Air conditioning systems. Choose from options like window units, split systems, or central air conditioning systems, considering factors like cooling capacity, energy efficiency, and installation requirements. Factors to consider. 1. Energy efficiency. Consider the system's energy efficiency, looking for options with high energy efficiency ratios or seasonal energy efficiency ratio (SEER). 2. Noise level. Consider the system's noise level, especially for installations in residential areas or noise-sensitive environments. 3. Maintenance and repair. Consider the system's maintenance and repair requirements, looking for options with easy access to components and simple maintenance procedures. 4. Budget and cost. Consider the system's upfront cost, operating costs, and potential savings over time. In conclusion, proper installation procedures, coupled with accurate system sizing and selection, are fundamental to achieving optimal performance in air conditioning and refrigeration systems. These processes ensure that the systems operate safely, efficiently, and environmentally responsibly. By adhering to industry standards and embracing best practices, we contribute to sustainability while meeting our cooling and refrigeration needs. Thank you for your attention, and feel free to ask any questions you may have. Thank you for attending this lesson. We hope to have you again in the next lesson. Happy learning, folks!